Okay, review and teardown of what's known as a recessed LED lighting panel. It's meant to be mounted into a wall or to a ceiling. It's got a couple clips on it. It's a really good example of what happens once you free yourself from the constraints of existing form factors. If you look at my YouTube channel, I've been reviewing a lot of LED light bulbs because it's a relatively interesting market from a business and engineering perspective lately. And those bulbs spend a lot of effort trying to build a emulation of an existing incandescent bulb. This is a very different approach, and also perhaps another endpoint for the market where you don't have to worry about the past and you can only go for the future. It's a 400 lumen panel. It's about 5 inches on square, and it was a remarkably cheap item. I'll just pop up the Amazon page where I snagged it from, just over $14. The panel seems to be actually offered by a number of vendors. I'm not sure if they're all identical to this one or if they're all simply knockoffs. It's hard to understand the provenance sometimes of material coming out of China. Anyways, we'll turn it on, see how it works, and then tear it down. This operation is fairly straightforward. It's a DC panel, and they supply an AC to DC converter. I presume it's a constant current device, and a barrel jack. You snap it together. The panel here is 6,500 Kelvin, so it's fairly white. I believe the vendor offers a number of lights. It's 3,500 and 4,500 Kelvin as well. And of course, as you can see, it's a very constant and consistent light. Okay, so this panel should produce a nice flat lighting. So what you do is you put them in a nice big array on a wall or a ceiling. You should probably create a very nice lighting effect if you did that. What I have here is its panels shining down upon a desk. Put a light meter down. The blue tabs, of course, are masking tape, and they just simply record the intensity of the light, 400, 405, 436, 438, 435, 270. Obviously, the intensity drops out as you get further from the panel, but within the spot area, they are all about consistent. So this looks like a good panel, actually, producing a nice, even light, so very appropriate. Okay, flicker test. This is a solar cell, and the light's obviously shining down upon it. And we look at an oscilloscope screen, you can tell whether or not there's flicker. And there isn't in this arrangement. Now the flicker is entirely a effect actually of the power supply. It's not the LEDs. They're of course quite capable of creating a flicker-free performance. So this power supply, not too surprising, quite a constant current driver, is providing no flicker. Now the next question of course is the panel dimmable. Okay, dimmer test, wired a dimmer in line, and basically there's only two modes, on or off. And that's not a function of the panel, but actually a function of the power supply that was provided. There should be no reason why you couldn't make this kind of panel with a dimmable power supply. In terms of what I purchased, however, basically not a dimmable setup. Okay, I just opened up the fixture here, and you can see a strip lighting. Those little yellow dots are LEDs, and they're mounted onto a strip, which then is adhesively attached to this inner ring. And in the center here, there was actually three more pieces of plastic. A piece of opaque white plastic, a piece of plexiglass, which looks like it has a honeycomb pattern etched onto it, and then another bit of opaque plastic. I presume, of course, these are what's allowing this bulb to have no hot spots, because these three pieces of plastic are diffusing the light quite nicely. And of course, I'm sure there's a penalty to be paid there, because there will be some loss of light through such a structure. So inside this little power supply enclosure, a very classic AC-DC converter, AC on this side and DC coming out this side. It has all the standard parts you would expect. There's a bridge rectifier, filtering capacitor for the input, I should imagine. It looks like a resistor which is acting like a fuse, a transformer. It does appear to be an isolated design, which is good, and then the output. So those are pretty straightforward topology, and it kind of explains why it's not dimmable. I don't think there's a lot of sophistication on the integrated circuits here. Okay, so basically this is a really good example of what you can do when you sort of free yourself from the constraints of the past, and you can produce LED panels which are quite novel. I certainly could imagine some interesting architectural applications of this, and how you could use a nice small array of panels like this to create a really pleasing visual effect. So I'm sure this actually will be another endpoint in the LED industry as it breaks free of the constraints of the past.